Hello, everyone. Today, I'm going to walk you through this lesson, and I'm excited to be learning with all of you. Last class, we described the Modbus protocol. This time, we'll focus on Modbus over serial communication. The Modbus standard defines Modbus over serial line, which is a protocol at the data link layer of the OSI model. It allows Modbus application layer protocols to communicate over a serial bus, as shown in the Modbus protocol and ISO OSI model diagram. The Modbus serial line protocol is a master-slave protocol that supports one master and multiple slaves on a serial bus. When using the Modbus protocol at the application layer, devices on the communication channel operate in a client or server mode. In Modbus over serial line, the master station takes on the role of the client, and the slave stations act as the servers. The naming conventions of the Modbus organization can be confusing. Traditionally, network communications are described using multiple clients and a single server. However, Modbus serial communication uses one client, master, and multiple servers, slaves. To avoid confusion, the RS-485 transport layer uses the terms node or device instead of server, and client is not a node. In Modbus over a serial line, up to 247 slave devices can communicate with one master device. These slave devices have unique addresses ranging from 1 to 247 decimal values. The master device does not need an address. The communication process is initiated by the master device, as only the master can start a Modbus transaction. Slave devices never transmit data or perform any operations without a request initiated by the master, and communication between slave devices is not possible. In serial Modbus, the master station initiates requests to the slave stations in either unicast or broadcast mode. In unicast mode, the master sends a request to a single slave with a specific address. After receiving and completing the request, the slave replies to the master. In this mode, a Modbus transaction consists of two messages: a request from the master station and a response from the slave station. Each slave station must have a unique address, from 1 to 247, for individual communication. In broadcast mode, the master station can send a request to all slave stations using the broadcast address 0, which is reserved for broadcast exchanges. Note that 0 is not the master station address. Slave stations must accept broadcast exchanges but cannot respond. Data travels from the application layer to the data link layer, completing the mapping of the Modbus PDU to the Modbus serial line protocol PDU. That is, Modbus serial line PDU equals address plus PDU plus CRC or LRC, where PDU is the PDU in the Modbus frame, consisting of a function code and data. Address is the slave station address. The error checking method with CRC/LRC depends on the Modbus serial protocol version. At the physical layer, Modbus over a serial line uses RS-485 or RS-232 for bit-by-bit communication, with the TIA/EIA 485 two-wire interface being the most popular method. The four-wire interface of RS-485 can also be used. RS-485 is a differential communication protocol that supports multi-point communication with multiple nodes, using two pairs of transmission lines, A, B, for bidirectional communication. Differential signaling helps to better resist line interference and noise. TIA/EIA 232E RS-232 can also be used, but it is limited to short-distance point-to-point communication. RS-232 is typically used for short-range communication, with a maximum communication distance of just a few tens of meters. The highest data transfer rate is usually 115.2 kilobits per second. RS-485 is suitable for long-distance communication, with a communication distance that can reach several kilometers. The transfer rate can reach 10 megabits per second, depending on the specific standard and equipment. Modbus over a serial line has two transmission modes, RTU and ASCII, corresponding to two versions of the protocol, namely Modbus RTU and Modbus ASCII. Modbus RTU. Modbus RTU, Remote Terminal Unit, is one of the most common implementations of Modbus. It communicates using a compact, binary data representation. The RTU format appends a cyclic redundancy check, CRC, checksum, after the command data as an error-checking mechanism to ensure data reliability. Modbus RTU messages must be transmitted continuously without any pauses between characters. Modbus messages are separated by idle, silent periods. Each 1 byte, 8-bit, data message in Modbus RTU requires an additional 3 bits, making a total of 11 bits. A Modbus RTU frame, as shown in Table 2.4, consists of 1 byte slave address, 1 byte function code, data, and 2 bytes CRC check. The byte data transmission order in Modbus RTU mode is illustrated in Table 2.5. Each byte of data is appended with 3 bits: the start bit, the stop bit, and the parity bit. The CRC check uses CRC16 Modbus, which calculates all bytes from the slave address to the data to obtain the CRC16 check result. In this lesson, we learned about 1. The frame structure of Modbus over serial communication. 2. The two transmission modes for Modbus over a serial line, RTU and ASCII, with a focus on the frame structure of Modbus RTU. That's all for this lesson. See you next time.